Let's continue talking about fabric device roles. In this case, we're going to talk about the wireless LAN controller within the fabric. In this case, it runs in fabric mode. And the operation of the wireless LAN controller in fabric mode is different from the traditional Cisco unified wireless network operational mode. There are some similarities that are kept, though. When working in fabric mode, the wireless LAN controller still is in charge of distributing access point images. It is a central point for the configuration management for my access points. It still manages the client sessions. It is in charge of mobility services, and the cap-WAP tunnels between the wireless LAN controllers and the access point still exist, but there is a detail that we should talk about now. When the cap-WAP tunnel traffic is sent from the access points to the wireless LAN controllers, this traffic will use the underlay of my fabric. So the access point will look for the IP address that belongs to the wireless LAN controllers in my global routing table that belongs to my underlay. It should exist there. Once it is found, then the traffic is sent through my underlay, and it is eventually sent to an external network to reach the wireless LAN controllers. Now the traffic that comes from the wireless LAN controller back to the access point will use the overlay. The access point, when trying to respond to the wireless LAN controller, when trying to respond to the access point, will look for this access point IP address within the global routing table here, and then it will respond, and when that traffic coming back reaches my fabric, then a VXLAN tunnel will be created to transport that traffic. Remember that there is also a VXLAN tunnel here between the edge node and the access point. So just remember that the access point traffic to the wireless LAN controller will use the underlay, and the traffic coming back, you will use the overlay. In order for this to work, my wireless LAN controllers should be operating in fabric mode, and my access points should be also operating in fabric mode. I cannot have a wireless LAN controller in fabric mode trying to work with access points operating in traditional mode, and I cannot make access points working in fabric mode try to operate with a wireless LAN controller that is operating in traditional mode. And notice that these access points will only use local mode. Remember that in traditional wireless networks, I can put my access points in different modes. For instance, flex connect mode. That is not possible here. They can only operate in local mode, and I should observe a latency of no more than 20 milliseconds between the wireless LAN controllers and the access point. So the recommendation here is to install the wireless LAN controllers in the same facilities where your fabric exists. So if you have a fabric in a building where all your access points are connected to, you must install your wireless LAN controller in the same building. There is the possibility to manage remote access points if you extend your fabric to another building. That could be remotely possible if you could have a wide area connection that offers you 20 milliseconds of latency. That is difficult, but if you have a carrier that could offer you that 20 milliseconds and your fabric is extended to another building, in that case, your wireless LAN controller could control access points that exist in a different building. But you'll have to make sure that all of these requirements are met. So this is what we're going to talk now is the biggest difference between the operation in fabric mode and comparing it with traditional operation. In fabric mode, the wireless LAN controllers are in charge of sending map register messages to the control nodes in order to inform them where the device, a wireless device, is connected to the network. Once a wireless device has been associated to the network, then the wireless LAN controller will send a map register message to the control nodes, so the control nodes will be able to update their host tracking database. Remember that this host tracking database maps endpoint IDs to RLOCs. In this case, the endpoint ID will be the MAC address that belongs to this device, and the RLOC will be the IP address that corresponds to the edge node that is connected to the access point that is serving this user. In this manner, we have one of the biggest advantages of running a fabric, because if another device wants to send traffic to this wireless device, then a VXLAN tunnel will get built, and the destination of this VXLAN tunnel will be this particular edge node, that is the edge node to which the access point that is serving this end user is connected to. Compare this with traditional networks. In traditional networks, if you wanted to send traffic to any wireless end device, you had to send that traffic to the wireless LAN controller. That no longer happens with the fabric. You just send it directly to the edge node to which the access point that is serving that user is connected to. Remember that there is also a VXLAN little tunnel between the edge node and the access point. As the user moves and we have a roaming scenario, then the wireless LAN controller will be in charge of sending another message to the control nodes in order for these control nodes to update their host tracking databases. In this case, the wireless device has moved to an access point that is connected to a different edge node, and then the host tracking database will be updated accordingly. Now the MAC address that belongs to this device will still be used as the endpoint ID, but now the RLOC has changed, and now it points to the IP address that corresponds to this other edge node. So with the help of Lisp, we have an easier way to handle mobility and roaming. When deploying your wireless LAN controllers, it is recommended to deploy them with high availability. So you will need at least 2 wireless LAN controllers. Remember, the wireless LAN controllers have a specific port in order to connect wireless LAN controllers to each other in order to create these clusters of wireless LAN controllers. And when configure these fabric mode wireless LAN controllers to operate within the fabric, you can configure 2 control nodes, the primary control nodes and a backup control node. So in that sense, this means that a pair of wireless LAN controllers can only be useful for one fabric domain. If you had a different fabric domain, another fabric domain in a different building, And if you set up a wide area connection that offered you 20 milliseconds of latency, you couldn't be able to use or reuse or leverage these wireless LAN controllers to handle a different fabric domain, because in order to do so, you will need the possibility to set up another pair of control nodes. But you have the limitation of only be able to set up a primary control node and a backup control node for your wireless LAN controllers. So one set of wireless LAN controllers can belong only to one fabric domain. And remember that your wireless LAN controllers are usually get connected to a shared service block or to on-premise data center, depending on what you have on your network. And they are usually connected in the same place where you connect your servers, your DHCP server, your DNS server, your Catalyst Center, formerly known as DNA Center, your iServer. That is where you connect your wireless LAN controllers. If you don't have a services block or a data center, that means that your network is smaller. You can connect your wireless LAN controllers to your border nodes. That is the recommended place. Or if you really have a really small site, you can run your wireless LAN controllers as virtual machines within your Catalyst devices. That is known as embedded wireless LAN controllers. So given your wireless LAN controllers are connected outside your fabric most of the time, then you must make sure that the IP address that belongs to your wireless LAN controllers is redistributed into the IS domain or whatever protocol you have for your underlay. Remember that in the underlay we have a global routing table that is created by a routing protocol. And in order for your access point to be able to talk with the wireless LAN controller that is connected outside the fabric, the IP address that belongs to the wireless LAN controller should exist in the global routing table. So for instance, if this wireless LAN controller had the IP address 10.1.1.1, then that IP address 10.1.1.1/32 should and must exist in the global routing table. You can also inject summaries, and that still will work. You could inject the 10.1.1.0/24, and that will work. You cannot rely on the default network, the default route in order to locate your wireless LAN controller within the fabric. That is not permitted. You need the /32 or a summary network for your wireless LAN controller within your global routing table in your underlay. In the same manner, remember that for your fabric, all your access points actually live in the same subnet. For instance, we could say that this access point lives in the network 10.10.10.0/24, and this is given the last octet of 1, and this is number 2, and this is number 3, and so on. Internally, this subnet is assigned into an overlay virtual network that is known as the infra VN. But this particular overlay virtual network is mapped into the underlay global routing table. So for practical purposes, you can think that the IP addresses that belong to your access points live in the global routing table of your underlay. And that prefix should be advertised into the external networks, so the wireless LAN controllers are able to locate your access point. So the network 10.10.10.0/24 should exist in the global routing table here. And given we are talking about sharing prefixes between global routing tables, we don't need a fusion device. So we don't need a fusion router because we are going to share prefixes between global routing tables. If you design your network to have a guest solution in the DMZ, then you will need another pair of wireless LAN controllers that you could call the guest wireless LAN controller. So if you're going to have guest traffic allowed in your corporate network, you're going to need 2 wireless LAN controllers for your guest traffic and 2 wireless LAN controllers for your enterprise traffic. And at the same time, you will need 2 control nodes for your guest traffic and 2 control nodes for your enterprise traffic. So you will need at least 4 wireless LAN controllers and 4 control nodes. We have so far shown a 3-tier design, but you could design for 1-tier and 2-tier networks depending on the size of your network. If you really have a small site, you can use a 1-tier design that is known as fabric in a box. That means that you only have one box, one device, and this device is at the same time the edge node, the control node, the border node, and within this device we can run a virtual machine and we can run an embedded wireless LAN controller. Now for small sites as well, you can choose to go for a 2-tier design, and in the first tier you have your edge nodes, and in your second tier you have your border nodes that at the same time are control nodes, and as virtual machines you can run your embedded wireless LAN controllers there. So what is the hardware that you will need? For actual wireless LAN controllers boxes, you can choose these using the newest generation of Catalyst wireless LAN controllers, or these for old generation of IronNets, or you can choose to go for the virtual option, and you can run embedded wireless LAN controller on Catalyst switches such as the 9300s, 9400s, and 9500s. That's it.